Hi, hello friends, welcome to T Academy. In this video, we will discuss some basic important questions which will be useful for the SSC JE exam as well as Digital Assistant or Panchayat Secretary Grade 6 in AP/CRAM or Sachivalaya. So for this reason, I am going to discuss these questions in both the languages of Telugu and English. Okay. So first question here. So it's a basic question. Okay, first I will read in English and later I will explain in Telugu also. Four resistances 2 ohms, 4 ohms, 5 ohms and 20 ohms are connected in parallel. Their combined resistance is. సో ఇక్కడ మన క్వశ్చన్లో 4 రకాలైనటువంటి రెసిస్టెన్స్ని ఇవ్వడం జరిగింది. వాటిని ప్యారలల్లో కనెక్ట్ చేస్తే దాని యొక్క ఈక్వల్ రెసిస్టెన్స్ ఎంత అని అడిగారు. ఫస్ట్ ఆఫ్ ఆల్ సిరీస్ కనెక్షన్ అంటే ఏంటి, ప్యారలల్ కనెక్షన్ ఏంటి చూద్దాం. సో సిరీస్ కనెక్షన్ మీన్స్ one end of the element is connected with the another end of the element, then it is called the series connection. Parallel connection means they are at equal potential points, అంటే రెండు సమాంతరంగా ఇలా కనెక్ట్ చేసుకున్నామంటే మనకు parallel connection. So these are the series connection, శ్రేణి సంధానం, వీటిని సమాంతర సంధానం అంటారు. సో parallel connection. Now ఈ క్వశ్చన్ ఏం అడిగారంటే there are 4 resistances అంటే 4 రెసిస్టెన్స్ ఉన్నాయి. 2 ohms, 4 ohms, 5 ohms, 20 ohms. అవి ప్యారలల్ కనెక్ట్ అయినాయి అంటే ఇలా కనెక్ట్ చేసుకున్నారు అనమాట. సో 1 3 తర్వాత ఇంకొక రెసిస్టెన్స్ ఇక్కడ మొత్తం 4 ఉన్నాయి. ఒకటి వచ్చి 2 ohms, 4 ohms, 5 ohms and 20 ohms. Suppose if they are connected in series resistance like this. So series means 2, 4 ohms, 5 ohms, 20 ohms. Okay. Now what is the equivalent value here? So series అన్నప్పుడు అన్ని వాల్యూస్ని యాడ్ చేసుకుంటూ వెళ్ళిపోవడమే. Series means adding all the values. Suppose if the R equivalent when connected in series is equal to 2 plus 4 plus 5 plus 20. So how much it is? So 25, 29, it is going to be 31 ohms. Suppose when they are connected in parallel, I will write the formula here. 1 by R equivalent is equal to, so 1 by, so let's say here the 4 resistance are there. We'll take it as a, let by R1, so 1 by R2 plus 1 by R3 plus 1 by R4. So 1 by R equivalent is equal to, so 1 by R means first value is a 2 plus second value is 4 plus 1 by 5 plus 1 by 20 here. So if you are solving this, so R equivalent will be, you are getting as a 1 ohm here. So the answer for this question is A is as a 1 ohm here. So like this, in the examination, if they ask any other values, just substitute the same pattern here. Here I discuss about the series connection, next I discuss about the parallel. So likewise, when they are giving in parallel connection, you just need to take this formula and do the calculation like this. So these two are the important formulas for examination point of view. Okay, so these two are the important formulas here. So when series means adding all the values. So exam lo manaku డిజిటల్ అసిస్టెంట్ ఎగ్జామ్ కానీ లేదా SSC JE ఎగ్జామ్ కానీ క్వశ్చన్ అడిగారంటే సిరీస్ కనెక్షన్ అయితే ఇచ్చిన వాల్యూస్ అన్నీ కూడా యాడ్ చేసుకోవడం, ప్యారలల్ కనెక్షన్ అయితే ఈ ఫార్ములాని అప్లై చేయాల్సి ఉంటుంది. ఓకే, సో విల్ మూవ్ టు ద నెక్స్ట్ క్వశ్చన్ హియర్. So first we will discuss in English, later we will discuss again here. So 2000 ohm 2 watt resistors are connected in parallel. Their combined resistance value and wattage rating are. So ఇక్కడ ఏమి ఇచ్చారంటే రెండు 2000 ohm resistors ఇచ్చారు, వాటి రేటింగ్ ఎంత 2 watts ఉంది. వాటిని మళ్ళీ ఇక్కడ ఏం చేశారు, ప్యారలల్ కనెక్ట్ చేశారు. సో ప్యారలల్ కనెక్ట్ చేయడం అంటే ఎలా చేయాలి, రెండు రెసిస్టెన్స్ ఇలా తీసుకుంటాం, వన్ రెసిస్టెన్స్ అనదర్ రెసిస్టెన్స్ ప్యారలల్ కనెక్ట్ చేసాం. సో ప్యారలల్ కనెక్ట్ చేసిన తర్వాత వాటేజ్ వచ్చి 2 watts ఇచ్చారు, రెసిస్టెన్స్ మనకి ఇచ్చారు ఎంత 2000 ohms. సో 2000 ohms ఆర్ గివెన్. ఓకే, 2 రెసిస్టెన్స్. వీటి యొక్క R ఈక్వలెంట్ వాల్యూ ఎంత, సేమ్ ఫార్ములా 1 by R ఈక్వలెంట్ ఈజ్ ఈక్వల్ టు 1 by R1 plus 1 by R2. సో అలా చేసామంటే మనకు ఎంత వస్తుందంటే వాల్యూ R ఈక్వలెంట్ ఈజ్ ఈక్వల్ టు, సో 1 by 2000 plus 1 by 2000. So finally, okay, so finally R equivalent will be 1000 ohms here. Okay, so there is one more shortcut here. Suppose okay value unnai ankondi, suppose if there is same value which are connected in parallel, suppose we can split here. So R equivalent when the same value is given in parallel means, so R value divided by n number of parallel paths. So for example, if you apply this formula here, R value is the same here. How many paths? 1, 2. So simply 2000 by 2 will give a shortcut of 1000 ohms here. Now we need to find the wattages here. Remember friends, either it may be series connection or it may be parallel connection, the value of the wattage will not change. So here series aina parallel aina sare wattage anedi maradu. So kabatti em ostundante total power PT is equal to, so this resistance will going to absorb 2 watts, this one also 2 watts, so total is going to be 2 watts plus 2 watts, it is going to be 4 watts. So answer ఏమవుతుందంటే 1000 ohms 4 watts అన్నమాట. Okay, next question here. సో ఇప్పుడు ఇంకొక డిఫరెంట్ క్వశ్చన్ ట్రై చేస్తాను ఇందులో. ఓకే, one more question. A stove element draws 15 amps when connected to 230 volts line. How long does it take to consume 1 unit of energy? ఒక స్టవ్ ఉంది మన దగ్గర. సో ఆ స్టవ్ అనేది ఏం చేస్తుందంటే 15 ఆంపియర్స్ ఆఫ్ కరెంట్ని తీసుకుంటుంది. ఓకే, దాని వోల్టేజ్ ఎంత అంటే ఇది 230 వోల్ట్స్ వోల్టేజ్ ఇచ్చేసాం మనం. ఓకే, హౌ లాంగ్ అంటే ఎంత టైం పడుతుంది? ఇట్ కన్జ్యూమ్స్ 1 యూనిట్ ఆఫ్ ఎనర్జీ. సో ఇక్కడ 1 యూనిట్ ఆఫ్ ఎనర్జీ అంటే మీనింగ్ ఏంటి అంటే, ఒక యూనిట్ అంటే 1 యూనిట్ మీన్స్ ఇట్ ఈస్ నథింగ్ బట్ 1000. ఓకే, సో 1000 ఎనర్జీ ఇన్ జౌల్స్. ఓకే, 1000 జౌల్స్ అన్నమాట ఎనర్జీ. ఓకే, సో ఇప్పుడు బేసిక్ ఫార్ములా ఏంటంటే, సో దిస్ ఈస్ P is equal to V into I. So this is also one important formula here. So power is in watts. So P is equal to V into I. Now if you want to find the energy, energy is nothing but V into I into T. Okay, so T is in here, it is in hours. So general unit is watt hour. Okay, units. So these two are the important questions. They may, in examination point of view, they may ask what are the units of power, what are the units of energy. So energy is nothing but kilowatt or watt hour we can take, or joules we can take. No, ఇప్పుడు ఇక్కడ క్వశ్చన్లో ఏమంటే ఎనర్జీ వాల్యూ ఒక యూనిట్ అన్నాడు కాబట్టి అదేమవుతుందంటే 1000 is equal to voltage is given how much, 230 into 15 into T. So T is equal to, so 1000 divided by 230 into 15. So you are getting it as 0.289 something. Its answer is 0.29 hour. So answer which D is the right answer for this question. And the next one here, so this is a basic question. This concept is based on the current division rule. So ఇది చాలా గుర్తుపెట్టుకోండి, current division rule. సో ఈ కరెంట్ డివిజన్ రూల్ ఏం చెప్తున్నానంటే, ఇక్కడ మనకు కరెంట్ సోర్స్ ఉంది, 2 ohms రెసిస్టెన్స్ ఇక్కడ ఒకటి ఉంది, 5 ohm రెసిస్టెన్స్ ఇక్కడ ప్యారల్గా ఉన్నాయన్నమాట. సో ఇప్పుడు క్వశ్చన్ ఏమడిగారంటే, ఫైండ్ ద కరెంట్ త్రూ ద 5 ohm రెసిస్టెన్స్. సో హియర్ ద కరెంట్, వాట్ ఆర్ ద కరెంట్ ఫ్లోయింగ్ హియర్, దట్ వీ నీడ్ టు ఫైండ్ హియర్. Okay, so remaining all the data available. Okay, now by using current division rule, as per the current division rule, suppose for example, if you want to find the current in any element, so current in the resistance of R should be equal to, so total current I into opposite resistance of the R value divided by opposite resistance plus R value. So based on this, applying this formula, so ఈ ఫార్ములా అప్లై చేసుకుంటే ఇప్పుడు నాకు ఇక్కడ R వాల్యూ ఎంత 5 ఉందా, సో I 5 is equal to total current ఎంత ఇక్కడ 10 amperes ఇచ్చాడు. సో ప్యారల్ ఉన్నాయి 10. R0 వాల్యూ ఎంత ఇక్కడ మనకు, సో R0 అంటే ఆపోజిట్ రెసిస్టెన్స్. సో 5 కున్న ఆపోజిట్ ఏంటి 2. సో 2 డివైడెడ్ బై 2 ప్లస్ 5. సో ఎంత అవుతుంది, సో 20 డివైడెడ్ బై, హియర్ ఇట్ ఇస్ 7. ఓకే, సో ఇట్ ఇస్ గోయింగ్ టు బి 2.85 amperes is the right answer for this question. Next question. So సో సిమిలర్గా ఇలాంటి క్వశ్చన్ ఇంకొకటి చూసాం ఇక్కడ. సో నెక్స్ట్ క్వశ్చన్ ఈస్ find the resistance R3 for the circuit shown in the figure. So where is that R3? R3 is here. Okay, here we need to find the current, find the value of R3 we need to find here. Okay, now the basic concepts that we are going to apply here, it is em apply chesam first మనకి ఇచ్చిన data చూద్దాం. Here just assume the apply KCL. So KCL, what it says, algebraic sum of currents at a node is going to be 0. That means current entering should be equal to current leaving. So example here, so let us assume I3 value. So if you apply the KCL at this node, so KCL at this node, entering currents, enter ఏమవుతున్నాయి ఇక్కడ, so 10 milliamperes sorry, plus I3 value is entering here. ఇవి రెండు ఈ నోడ్ దగ్గరికి వస్తున్నాయి. సపోజ్ మీరు ఇక్కడ నిలబడుకున్నారు అనుకోండి, if you are standing here, the current is entering here, the current is entering here, and what is the current, what about the current leaving here, so which is equal to 50 milliamperes. Now I3 value will be what, it is going to be 40 milliamperes. Okay now సో ఇది ఒక కాన్సెప్ట్ అయింది. నెక్స్ట్ ఇంకొక కాన్సెప్ట్ ఈ ఫార్ములా నుంచి నేర్చుకుందాం మనం. ఇంకొకటి ఏమంటే వోల్టేజ్ ఫార్ములా V is equal to I into R. సో ఇక్కడ మనం వోల్టేజ్ చూసుకున్నామంటే ఈ 2 పాయింట్స్ మధ్యలో V ఎంత ఉంది, V is equal to మనకు కరెంట్ వాల్యూ ఎంత, ఇక్కడ 10 milliamperes అన్నారు. సో 10 milliamperes the current flowing here into R value is what, 100. Now milli means we know, so milli means what, it is nothing but 10 power minus 3. So 10 into 10 power minus 3 into 100 volts. So it is going to be how much, 1 volt here. So we got the value of voltage here. So manaku parallel lo common point enti, so parallel connection common point is, in a parallel connection so voltages are going to be same. అంటే ఇక్కడ ఏ వోల్టేజ్ ఉందో ఇక్కడ కూడా సేమ్ అదే వోల్టేజ్ ఉంటుంది. సమాంతర మనం సమాంతర సంధానం అంటాం, ఓకే తెలుగులో. సో when the parallel connection is there, the voltage will be same here. So whatever the voltage drop here, the same voltage drop will be here also. So for that reason I will consider here the voltage will be what, V. Okay, so V is how much is going to be 1 volt here. Now in the second case here, so here we know the voltage, we know the current, can we find the resistance, apply the same formula here. So V is equal to I3 into R3. So I3 value మనకు కనుక్కున్నాం ఎంత, it's going to be 40 milliamperes. So from this reason, so we can say R3 is equal to V divided by I3. So it is going to be V value is 1 divided by I3 is 40 into 10 power minus 3. So 1000 divided by 40. So it is going to be 25 units into resistance key, it is ohms. So answer here it is 25 ohms is the right answer for this question here. So we'll move to the next page. The next question on the screen is, in this question, superposition theorem can be applied only to, okay, superposition theorem is applied only to the linear networks. Okay, suppose linear networks అంటే ఏంటి సార్, ఎక్కడైతే మనకు voltage and current relationship, wherever the voltage and current relationships are linear and they are passing through the origin, then we can say it as a linear elements here. Okay, suppose if you take the diode characteristics, it is really like this. So voltage and current, so it is non-linear. So we cannot apply superposition theorem to non-linear networks or bilateral networks. Okay, linear bilateral networks we cannot apply here, only we can apply to linear networks only. Next one, Vennens theorem. So Vennens theorem cannot be applied to, so Vennens theorem cannot be applied to the non-linear circuits. Okay, so cannot be, understand here, cannot అంటే అప్లై చేయలేము మనం. ఓకే, సో ఇక్కడైతే మనకు డయోడ్ సర్క్యూట్స్ ఉంటాయో, ఎస్పెషల్లీ డయోడ్స్ కానీ, బీజేటీ కానీ, తర్వాత మాస్ఫెట్ కానీ, ఇవన్నీ కూడా మనకు నాన్ లీనియర్ సర్క్యూట్స్. ఓకే, ఎక్కడైతే ఉంటే మనం అప్లై చేయలేము. సో వీ కెనాట్ అప్లై Thevenin's theorem to the circuits which contains diode or BJT or MOSFET or SCR or somewhere else. Okay, they all are electronic devices. So where we cannot apply this Thevenin's theorem here. Next question. So next we will discuss about the series RLC AC circuit. So series RLC circuit means resistance, inductance and capacitance. Okay, so when we apply this circuit with the AC side analysis, okay, series RLC circuit resonance. So resonance means where the inductive reactance is equal to capacitive reactance. ఇక్కడ వాల్యూ XL ఉంటుంది, ఇక్కడ XC ఉంటుంది, ఇక్కడ R ఉంటుంది. జనరల్గా కాన్సెప్ట్ ఏంటంటే ఇండక్టివ్ రియాక్టెన్స్ కెపాసిటివ్ రియాక్టెన్స్ ఇప్పుడు ఆపోజిట్గా ఉంటాయి. అంటే XL ఈజ్ ఆపోజిట్ టు XC. ఓకే, ఇవి ఎప్పుడు కూడా జీరో ఉండాలి. ఈ కండిషన్ని మనం ఏమంటామంటే విల్ టాక్ ఇట్ యాజ్ ఏ రెజొనెన్స్ కండిషన్. So we'll say as a resonance condition when the inductive reactance and the capacitive reactance are made equal here. Now, if we are equal, even that these two are equal, what about the reactance, net reactance? So net reactance is going to be 0 here. So net reactance అనేది 0 అవుతుంది. Okay. So ఇప్పుడు ఏమవుతుందంటే entire voltage is applied across this resistor only. So resistor మనకు తెలుసు ఏంటి పవర్ ఫ్యాక్టర్ ఎలా ఉంటుంది. For a resistive element the power factor is that is nothing but cos phi is unity, అంటే ఇది 1 గా ఉంటుంది అనమాట. So for a series RLC AC circuit at resonance the circuit is behaving as a resonance condition and it's having a unity power factor and it is having a current is maximum. So current is maximum is, so current maximum or why current is maximum? So current is maximum because the reactance offered by the circuit is going to be 0. So Z is nothing but square root of R plus XL minus XC. So when XL minus XC becomes 0, R square here, Z is going to be R. So there is a one more point about this series resonance circuit is ఈ series resonance circuit ని మనం ఇంకో పేరు ఏమంటామంటే examination point of view important acceptor circuit. Series resonance circuit is also known as acceptor circuit. Series resonance circuit, other name is known as acceptor circuit here. Similarly, if I say about parallel resonance, parallel resonance, I can say it as a rejector circuit. So rejector circuit here. Okay, there is a one more point about this here, it is quality factor. Okay, I will discuss one more question here. So these are the important points regarding the examination point of view. Okay, quality factor. So quality factor is nothing but resonance frequency divided by bandwidth. Okay, so resonance frequency divided by bandwidth here. Okay, now next question here, as you can see, next question ఏమంటే bandwidth of an AC series circuit consisting of RLC is. సో bandwidth ఇక్కడ ఏం కనుక్కోవాలంటే, సో జనరల్గా మనకు డెఫినేషన్ ఉంది. సో bandwidth is nothing but it is the R by L here. Okay, so quality factor అంటే ఏంటి? సో Q is nothing but resonance frequency or omega R also రాసుకోవచ్చు. omega R FR అన్న ఒకటే. Omega is nothing but radians and frequency is in hertz here. So radians per second divided by omega R divided by bandwidth here. Now bandwidth ante enti? So bandwidth is nothing but it's a difference between the higher cutoff frequency minus lower cutoff frequency. Okay, so bandwidth kuna inkoka formula enti? So bandwidth is equal to resonance frequency divided by quality factor. So ivi chala important friends, examination point of view they are very important. Okay, so whatever I am saying here, keep it as a very important. Why? Because any point may be occur in, any ఏదైనా పాయింట్ అసలు మీ ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూ రావచ్చు అనమాట. ఇవి చాలా ఇంపార్టెంట్ పాయింట్స్. సో ఈ వీడియోని పక్కాగా ఫస్ట్ నుంచి లాస్ట్ వరకు కంప్లీట్గా చూడండి, ఎందుకంటే ఈ టాపిక్ నుంచి మ్యాక్సిమం మీకు డిజిటల్ అసిస్టెంట్కి క్వశ్చన్స్ ఇవ్వడం జరుగుతుంది. సో దీనికి మించి పోయే ఛాన్స్ అయితే లేదు. ఎందుకంటే ఈ ఎగ్జామ్ అనేది కామన్గా డిప్లొమా స్టాండర్డ్లో ఉంటుంది. తర్వాత అందరికీ కూడా ఎంబీఏ ఎంసీఏ వాళ్ళు కూడా అప్లై చేస్తారనమాట. ఓకే, వాళ్ళకు కూడా బేసిక్ క్వశ్చన్స్ ఇస్తారు తప్ప ఎక్కువగా బియాండ్ ద సిలబస్ ఎక్కువగా మనకి ఎలక్ట్రికల్ ఇంజనీరింగ్లో గేట్ క్వశ్చన్లు అలా అడిగేదేం ఉండదు. సో ఓకే, కాబట్టి ఎస్ఎస్సి జేఈ క్వశ్చన్స్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్. ఓకే, ఎందుకంటే ఇవన్నీ కూడా మీకు డిప్లొమా స్టాండర్డ్లోనే ఉంటాయి, ఎక్కువగా డెప్త్గా వెళ్ళవు. కాబట్టి ఆ క్వశ్చన్ చెప్తున్నాను. సో దిస్ వీడియో is very important for competitive exams such as digital assistant and SSC JE exams. Why? Because they will cover the basic questions only. They will not going to beyond the syllabus. Okay, they will not going to ask the gate questions. So they are very basic questions they are asking. Okay, now, so for this question, as you know, the answer is R by L is the answer. Okay, there is a one more point I will discuss here, the same point to avoid confusion. So time constant వస్తుంది. So time constant ఉన్నప్పుడు tau is equal to L by R here. So గుర్తుపెట్టుకోండి, ఇక్కడ R by L వస్తే bandwidth. Okay, when it comes L by R, it is going to be time constant here. Don't confuse with this one. Okay, time constant is this one. In examination point of view, you are going to confuse with this point only. Okay, next question. Next question. See, which of the following is a valid value of coefficient of coupling between two inductors? So what is a valid point here? So first of all, I will discuss what is the coefficient of coupling here. So when the two coils are there like this, they are connected through magnetically with the help of an core here. So this material in between these two windings is nothing but a core, and this is a primary winding and this will be secondary winding. Whenever the current flowing through it, it causes a magnetic flux like this. So whenever the magnetic flux links with the coil, there will be EMF induced, that is called transformer action. Now here we will talk about the coefficient of coupling. So coefficient of coupling. So coefficient of coupling will tell about how much tightly these two coils are coupled together. Now K is nothing but the formula is M divided by square root of L1 and L2. So where L1 is the inductance of the primary winding, L2 is the inductance of the secondary winding, and M is the mutual coupling between these two. Okay, so actual value K value is in between 0 less than K less than 1. So K kanna takuga K anedi in between 0 to 1 undali. So K value should be in between 0 to 1 here. But in the given question, see, all the values are greater than 1. So the answer here it is K value is always less than 1. Especially for SSC JE examination. So this formula is very important. So based on this, they will give a lot of questions are here. Okay, next question. Next question here. Application of Vennens theorem in a circuit results in. సో అప్లికేషన్ అంటే థెవెనిన్స్ థియరం వాడితే ఏమవుతుంది? సో థెవెనిన్స్ థియరం ఏం చెప్తున్నా అంటే ఏదైనా ఒక నెట్వర్క్ ఉన్నప్పుడు ఆ నెట్వర్క్లో ఉన్నటువంటి వోల్టేజ్ సోర్సెస్ని, ఓకే, తర్వాత ఉన్నటువంటి రెసిస్టెన్స్ని అన్నిటిని కూడా కంబైన్ చేసుకుని దాన్ని ఒక ఈక్వలెంట్గా ఎలా మార్చుకుంటామంటే one voltage source in series with the resistance here. So that voltage source is called VTH, resistance called RTH. So this is about the equivalent circuit here. Thevenin's theorem says that it contains many number of voltage sources and resistances together, okay, which can be remodeled as a single voltage source in series with the resistance here. So voltage source in series with the impedance or impedance in series. So answer is this one. Now there is a one more question here from this question itself. What about if they ask about Norton's theorem? So Norton's theorem, okay, so Norton's theorem means the answer will be if any network containing voltage source and resistances, they can be represented as a current source and an impedances in parallel. So this can be remodeled as a current source in parallel with this resistance here like this. The current source you can call as a IN, the resistance you can call as a RN. So one more important conclusion here, it is RTH should be equal to RN here. So this is also important question here. Now E point from this question, well, I will try one more question here. What is a dual? So Thevenin's theorem is a dual of Norton's theorem, or Norton's theorem is a dual. Okay, so dual theorem. Okay, ఇది కూడా చాలా ఇంపార్టెంట్ ఫ్రెండ్స్ మనకు. నెక్స్ట్ వన్. ఓకే, నెక్స్ట్ క్వశ్చన్ చూడండి. Superposition theorem requires as many circuits as to be solved as there are sources. ఎందుకంటే సూపర్పొజిషన్ థియరంలో మనకు ఎన్ని నెంబర్ ఆఫ్ సోర్సెస్ ఉంటే అన్ని చేయాలి. సపోజ్ మనకు ఒక 2 సోర్సెస్ ఉన్నాయనుకోండి, ఆ స్టెప్స్ని మనకు 2 సోర్సెస్ తీసుకోవాలి. ఎందుకంటే సూపర్పొజిషన్ థియరంలో ఒకసారి మాత్రమే ఒక సోర్స్ తీసుకుంటాం. సో we will take one source at a time, okay, for each step. So superposition theorem requires as many circuits as to be solved as there are number of sources are there. Suppose there are 5 sources, we need to solve the same problem with 5 steps here. Okay, understand? Now, so this question here, a voltage source having open circuit voltage of 150 volts and internal resistance of 75 ohms is equivalent to a current source of. సో మన దగ్గర ఒక 150 volts సోర్స్ ఉందండి. సో ప్లస్ ఆర్ మైనస్ తీసుకుందాం. 150 volts సోర్స్ ఉంది. ఓకే, ఇది ఎంత ఇంటర్నల్ రెసిస్టెన్స్ అంటే ఎంత ఉంది? ఇంటర్నల్ రెసిస్టెన్స్ అంటే మనం చూసుకున్నాం 75 ohms ఉంది ఇక్కడ. సో 75 ohms ఉంది. ఓకే, సో ఇలా ఉందన్నమాట. సో దీన్ని మనం కన్వర్ట్ చేసుకోవాలి. ఏంటి? కరెంట్ సోర్స్గా మార్చుకోవాలి. సో ఇంతకుముందు just now we discussed one point here, that we can convert any voltage source into its Norton's equivalent here, as you see. So similarly we will convert here. How we are going to convert, sir? That's an important point here. Now I am going to convert from this. So here I am going to convert, find the value of IN is nothing but VTH divided by RTH. So ఇక్కడ ఇచ్చిన వాల్యూని ఓపెన్ సర్క్యూట్ వోల్టేజ్ ని థెవెనిన్స్ వోల్టేజ్ గా తీసుకోవచ్చు. RTH value will be 150. So here I am taking this VTH as open circuit voltage and internal resistance 75 ohms as a RTH value. Now from this case, IN is equal to how much voltage you are getting? 150 volts divided by RTH value is how much? 75. So we are going to find as a 2 amps is the answer here. Now I need to find the resistance. Just now we discussed the point here, that here I discussed the point that RTH is equal to RN. So whatever the RTH value is there, the same value should be get as a RN value. So here RTH value what you have taken here, RTH is nothing but RN is equal to how much? 75 ohms. So answer is the current will be in 2 amperes. Current will be 2 amperes here, which is in parallel with the resistance of 75 ohms here. So answer will be 2 amperes is in parallel with 75 ohms is the right answer. Okay, next one more question here. So this topic we will going to cover all the important questions for SSC JE examination and especially for digital assistant examinations of Gramavat Sachivalayam. An ideal voltage source should have, okay, remember here that I will going to clear your concept. An ideal voltage source, either it may be AC or it may be DC. So let us consume, I am considered AC here. It will have internal resistance here like this. Okay, now so let us consume VTH and RTH here. This is a voltage source. ఈ voltage source మనకి ఏం చేస్తుంది? voltage ని ఇక్కడ ఇవ్వాలి మనకు. ఓకే, ఇక్కడ resistance ఏం చేస్తుందంటే it is going to create some drop. So it's going to create voltage drop resistance. For example, మనం ఇక్కడ 100 volts ఇచ్చాం. If you give 100 volts, suppose because of some resistance here, it is going to consume, it is 50 volts. What about the remaining voltage here? 50 volts. Suppose for example here it is a 20 volts. What about here? 80 volts. Suppose it's 0 volts. What about here? 100 volts. Understanding here? So an ideal voltage source should deliver the same voltage to the load. There should not be no drop here. So because of that reason, an ideal voltage source should have zero internal resistance, or I can say zero source resistance. So very important question point of view, examination point of view. Okay, especially when the SSC JE and other competitive exams. Okay, now here similarly, suppose if I talk about the same, instead of taking this source, if I take the voltage meter, or you can say voltmeter, at that time if you are talking about the voltmeter, so this is the voltmeter. Understand here, if it's a source, I'm giving a symbol like this, plus or minus, or source like this. Now this resistance here like this. Okay, suppose if it's a voltmeter connected across some resistance here, okay, the current should not flow here, and a current ఇక్కడ రాకూడదు అన్నమాట. So for that reason resistance should be infinite here. For an ideal voltmeter, the infinite source resistance should be there here. Okay, these two values are important, so I'm saying it as a very important one. Okay, similarly, suppose if you talk about the ideal current source, so ideal current source కి ఏమి ఉండాలి, ideal current source కి అయితే, so current source here, resistance should be here. See, కరెంట్ అనేది కంప్లీట్గా ఇలా వెళ్ళిపోవాలి, ఇక్కడ డైవర్ట్ అవ్వకూడదు. అప్పుడు ఏమవ్వాలంటే రెసిస్టెన్స్ అనేది ఇన్ఫినిటీ అవ్వాల్సిందే. అదే మనకు ఐడియల్ అమ్మీటర్. సో ఐడియల్ అమ్మీటర్ అయినప్పుడు మనకు కరెంట్ ఎలా వెళ్ళాలి, సో కరెంట్ అనేది టోటల్గా వచ్చిన కరెంట్ అనేది ఇక్కడ బైపాస్ అయిపోవాలి. ఓకే, వచ్చిన కరెంట్ అనేది ఇలా బైపాస్ అవ్వాలి, కాబట్టి రెసిస్టెన్స్ అనేది 0 ఉండాలి. సో అండర్స్టాండ్ దిస్ పాయింట్ హియర్, where an ideal voltage source should have 0 source resistance and ideal voltmeter should have infinite source resistance. Similarly, an ideal current source will have infinite resistance. Ideal ammeter should have 0 internal resistance. So in this question we covered around 4 questions here. Okay, next one. This question is from the network theorems. Okay, using Millimans theorem, find that currents through the load resistance RL of, this will be 4 ohms here, 4 ohms resistance shown below. So RL value here it is a 4 ohms, printing mistake. Okay, now by using the Millimans theorem, first we are going to find the output voltage. So output voltage we are going to find out from here. Okay, so V output here we are going to calculate. The basic formula is V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3. ఇక్కడ ఎందుకు, so here we have 3 elements are there. Here we don't have any resistance here. Okay, we have resistance but we don't have any voltage source here. So first we are going to find the output voltages divided by 1 by R1 plus 1 by R2 plus 1 by R3. Now V output voltage will be, so first one it is V1 is 8 by 3 plus V2 is 16 by 3 plus 24 by 3 divided by 1 by 3 plus 1 by 3 plus 1 by 3. So it is going to be 48 divided by 3 divided by 1. So it's going to be 16 volts. So ఇప్పుడు మనకి ఏం కావాలి, కరెంట్ కావాలి. Okay, we need to find the current here. So I is equal to V by R. So 16 divided by 4 is going to be 4 amps is the answer for this question here. Okay, so hope you understand this theorem here, and we'll move to the next question. Next question here. Okay, it is from the maximum power transfer theorem. So as per the maximum power transfer theorem, the efficiency normally obtained in a circuit under condition of maximum power transfer theorem. Whenever you see the maximum power transfer, okay, the efficiency is going to be only 50%. So efficiency is going to be only is 50% here. Next question here, so basic questions. Now Vennens equivalent voltage and resistance between the VAB for the network shown in below. So ఈ నెట్వర్క్ కి మనం ఏం చేయాలి, మనం థెవెనిన్స్ వోల్టేజ్ కరెంట్ కనుక్కోవాలి, థెవెనిన్స్ వోల్టేజ్ కనుక్కోవాలి, రైట్. సో థెవెనిన్స్ వోల్టేజ్ కనుక్కోవాలంటే ఫస్ట్ మనకి ఇక్కడ పాయింట్ ఉంది కాబట్టి దీన్ని మనం VAB అనుకుందాం. సో బై హియర్ we are going to use the nodal analysis. So nodal analysis. As per the nodal analysis, whatever the voltage you are taking, it is superior. Okay, so based on this concept, I'm going to apply. So superior means whatever the current it is going to deliver here. So current directions level కాబట్టి మనం current తీసుకుంటాం. So VAB, so it is a higher value. So this will be lower value, means we will differentiate minus 10 divided by 5 plus VAB minus 20 divided by 15 is equal to 0 here. Now VAB, by solving this, VAB by 5 minus 2 plus VAB divided by 15 minus 20 by 15 is equal to 0. If you are going to solve this VAB, you are going to have a 12.5 volts వస్తుందన్నమాట. ఓకే, సో సూపర్పొజిషన్ థియరమ్ అక్కడ సుపీరియర్గా ఉందంటే ఇక్కడ నుంచి మాత్రమే కరెంట్ వెళ్తుంది. ఇది అన్నిటికన్నా హైగా ఉంటుంది. అంటే VAB వాల్యూ ఈస్ గ్రేటర్ దాన్ 10 అండ్ VAB వాల్యూ ఈస్ గ్రేటర్ దాన్ 20 ఇస్ మీనింగ్. సో కాబట్టి ప్లస్ వాల్యూ తీసుకోవడానికి 12.5 వచ్చింది. ఇప్పుడు ఈక్వల్ రెసిస్టెన్స్ కావాలి. సో ఈక్వల్ రెసిస్టెన్స్ కావాలంటే, సో in Thevenin circuit we need to find Rn value. So we need to find the Rn value, means what we will do is Rn value first make it as a source is shorted. So this is the concept of this Thevenin theorem. So ఇప్పుడు Thevenin theorem యొక్క ప్రొసీజర్ చూస్తున్నాం మనం. సో ఒకవేళ Rn వాల్యూ కనుక్కోండి లేదా RTh వాల్యూ కనుక్కోండి అంటే ఏం చేయాలి? What we need to do to find the value of RTh? So simply make this voltage sources as a short here. So if you make the voltage source as a short, take the diagram here. So this is 5 ohms. I made the voltage shorted here. This value made short here, and here is one more point. Here there is one more resistance is here, and again this is also shorted, connected like this. So point A and B here. Okay, 15. If you redraw the circuit here between the point A, so this is going to be 5 and this is going to be 15. So now these two are in parallel. Manaku telusu. Okay, we have done already some portions here. When the two resistors are in parallel, 1 by R equivalent is equal to 1 by 5 plus 1 by 15. Okay, so if you are going to solve this, you are going to answer as a 2.5 ohms here. So that means we can redraw the circuit as between the terminals A and B. We can say it as a VAB in series the resistance like this. So VAB value is 12.5 and this resistance will be what? It is going to be 2.5 ohms here. So this is the equivalent resistance here. So answer is B here. Next one, basic important question here, the unit of permeability. So first of all, we'll discuss about the magnetic flux density. So magnetic flux density P is equal to 5 by A. Units are Webers per meter square. So this question is very important. Why? Because it is asked in so many exams. Okay, so Webers per meter square, or other units is Tesla. So next మనకి ఏం కావాలి? పర్మియబిలిటీ కావాలి. సో ఇంకో రిలేషన్షిప్ తీసుకుందాం. P is equal to mu naught mu R into H here, or we can write as a mu into H. So mu is nothing but the permeability. So permeability here. So from this mu is equal to B by H. Okay, so B by H. H అంటే మనకి ఏంటి ఫార్ములా తెలుసు మనకు? H is nothing but NI by L. That means ampere turns per meter. Now ఇప్పుడు ఇక్కడ B మనం mu వాల్యూ వేసుకుంటే, సో B వాల్యూ మనకు తెలుసు. B అంటే ఏంటి? Webers per meter square. So Webers per meter square into 1 by means meters divided by ampere turns. So meter gets cancelled. Weber by ampere turn meter. సో ఈ క్వశ్చన్లో మనం 3 క్వశ్చన్స్ని మనం కవర్ చేసాం అనమాట. ఓకే, సో ఆన్సర్ ఏమవుతుంది మనకు? వెబర్స్ పర్ ఆంపియర్ టర్న్ మీటర్. సో ఆన్సర్ ఈస్ C is the right answer for this question. So these are the important questions from this question here. Okay, next one more question here. Just previously we did one question here based on the concept of nodal analysis. Okay, so we are going to repeat the same question here. See here how we are going to find here. Now nodal analysis VA. it is going to be superior potential. So VA minus 12 divided by 1 plus VA divided by 1 ohm plus VA minus 6 divided by 1 ohm. Suppose understand here, if it's a plus minus, you're going to take minus here. Suppose if it's a ulta, minus plus here, then you're going to take here plus. Understand here. Now as per the question, it is only plus minus, so this is going to be 0. Now from this here, VA plus VA plus VA means 3VA minus 12 means it's going to be minus 18 is equal to 0. So from this VA is equal to 18 by 3, it is going to be 6 volts here. So answer is 6 volts is the right answer for this question. So similarly, I'll give one more question here, but here I am taking the current source here. Okay, so this model is important. Now again same nodal analysis I'm going to follow. In the nodal analysis, VA is higher potential. So VA minus 1 divided by 2 plus VA by 2, and the current is entering here. When the current is entering, consider as a minus sign. So minus directly 3 is equal to 0. That's it. Okay. So why? Because nodal analysis is a combination of KCL plus Ohm's law. Okay. So if you want this basics video, I have already done the video on these questions, so you can go through it a video. Okay. So I will provide the description. I will provide the link for these videos. Okay, basic questions. Now VA by 2, VA by 2 minus 3 here. So what's the answer will get it is VA by 2 VA means VA minus 1 by 2 minus 3 by, so 3 is equal to 0 here. Okay. Now VA is equal to 3 plus 1 by 2. So 3 by 6, 6 plus 1 by 2, it is going to be 7 by 2. It's going to be 3.5 volts is the answer here. Okay, so for this question, B is the right answer here. So next question is all about the AC circuits here. So AC circuits also very important one. The voltage across RLC are 3 volts, 14 volts and 10 volts are respectively as shown in the figure. Okay, if the voltage source is a sinusoidal, then the input voltage in RMS. Understand here, this type of questions you need to focus on the formula here. So voltage source Vs is equal to square root of the voltage of the resistance square plus VL minus Vc and magnitude whole square here. Now directly substituting the formula Vs is equal to square root of Vs. Why? Because we are talking about AC source here. We are talking about AC source. So ఈ క్వశ్చన్ లో AC సోర్స్ ఎప్పుడైతే ఇస్తాడో అప్పుడు మీరు ఈ ఫార్ములా అప్లై చేసుకోవాల్సి ఉంటుంది. VR వాల్యూ ఎంత ఇచ్చారు? R వాల్యూ ఎంత? 3. సో 3 స్క్వేర్ ప్లస్ ఇక్కడ చాలా గుర్తుపెట్టుకోండి, VL మైనస్ VC చేయాలి. సో VL అంటే 14 మైనస్ 10, ఎందుకంటే 10 ఉంది VC అంటే. సో ఇది వాల్యూ VC వాల్యూ, దిస్ విల్ బి VL value here. So whole square. So if you are doing so, square root of 9 plus 4 square here is nothing but square root of 25. Answer will be 5 volts. So in these questions, generally the examiner will give will perfect square root here. Okay, they will not change the values. They will ask perfect square root anamata ilanti questions lo especially. Okay, most of the questions lo answer nenu chusindi ante 5 volts untundi anamata answer. So 5 volts here. Next, one more question here. In a series RL circuit supplied from a sinusoidal voltage source, voltage across R and L are 3 and 4 volts respectively. The supply voltage is then. So it's a practice question. Vs is nothing but square root of 3 square plus 4 square is nothing but 5 volts here. So answer is 5 here. Next question. Ampere second is a unit of, for example, ampere seconds. So generally current is nothing but dq by dt here. So from this, q is equal to I into t. Okay, so I అంటే ఏంటి? కరెంట్ ఆంపియర్స్, t అంటే సెకండ్స్. దేనికి? ఇది చార్జ్. సో కూలూమ్స్ కి ఇంకో యూనిట్ ఏంటి అంటే COLUMBS. కూలూమ్స్ కి ఇంకో యూనిట్ అంటే ఆంపియర్ సెకండ్. ఓకే, ఆర్ కూలూమ్స్ ఆర్ నథింగ్ బట్ ఎలక్ట్రిక్ చార్జ్. సో మనం రీసెంట్గా TNEB ఎగ్జామ్లో దీనికి సంబంధించి క్వశ్చన్ అడిగారండి. ఏంటంటే the question asked in TNEB is if the current is say 4 amperes, okay, current is say 10 amperes, sorry, 10 amperes, and the time is 4 minutes, what is the value about Q here, question mark. Okay, so for this one we know the formula. So Q is nothing but I is nothing but 10. So T is in hours or minutes, so T is in seconds here. So T in seconds means 4 minutes. I'll convert into seconds means 60 here. So 2400 coulombs. So this is also one of the question which we are going to cover in this video here. Next one, if the resistance is 20 ohms and inductance is 2 Henry in a RL series circuit, the time constant of the circuit is, okay, so this is an important question which we discussed in the earlier. So tau, time constant is equal to L by R. This is when the RL series circuit. So tau is equal to RC when it is an RC circuit here. Okay, so in this question we will cover two questions here directly. So L by R means L value is how much? 2 divided by resistance is 20 is nothing but 0.1. So time constant units enti seconds anamata. So 0.1 seconds here. Suppose ikkada same value lo avana 2 farads icharu. So 2 farads. So same also. Appudu em avutundi time constant anedi 2 into 20 is nothing but 40 seconds here. Okay, so 2 farads ఇచ్చినప్పుడు 20 ohms ఉన్నప్పుడు ఏమవుతుంది 40 seconds అయిపోతుంది. సో అండర్స్టాండ్ హియర్ RL సర్క్యూట్ అయితే L by R, RC కి అయితే tau is equal to RC వస్తుంది. సో this cover two questions here. Next question here. In a series circuit, resonance circuit, the impedance at the half power frequencies. So half power frequency అంటే ఏంటంటే కరెంట్ వాల్యూ అనేది IRMS is equal to IM by √2 అవుతుంది అనమాట. అంటే పవర్ ఫ్యాక్టర్ ఏమవుతుందంటే ఇక్కడ 0.707 అవుతుంది. సో బేసిక్ కాన్సెప్ట్స్ ఉన్నాయి. సో ఇంపిడెన్స్ ఇక్కడ ఏమవుతుందంటే Z is equal to square root of R square plus XL square. At half power frequencies, just remember this point here, X is going to be R. So because of that reason, square root of R square plus R square is nothing but 2 R square square root is nothing but square root to the inverse of R here. Units are ohms. So at half power frequencies, X is going to be R and Z is going to be √2 times that of R here. The next question here, the humans are more vulnerable to electric shock. ఓకే, సో హ్యూమన్స్ ఆర్ మోర్ అంటే ఎక్కువగా దేనికి ఎఫెక్ట్ అవుతారంటే ఇక్కడ మనకు ఫ్రీక్వెన్సీ ఎప్పుడు అవుతుందంటే మనకు 50 years దగ్గర ఉన్నప్పుడు మనకు ఎక్కువగా ఎఫెక్ట్ అయ్యే ఛాన్స్ ఎక్కువ ఉన్నాయి అనమాట. ఓకే, సో నెక్స్ట్ క్వశ్చన్. Okay, so we are going to the last session for this question. So we covered almost 50 important questions in this video along with the examples. Now the last question here in this video is find the value of R so that the current through RL is 0. So here, what is the value of RL here so that the current through the R is going to be 0 here. So see here, if the current is coming here, it will have this node, it will see there are two paths. So current ikkada raagane manaku two paths untayi. Current either ilagana vellachu, ilagana vellachu. So current may flow in this manner or in this way. Now current will prefer, so I'll say current always prefer low resistance so path. Understand this point here. So current ikkada raagane chustunnaru ikkada low resistance undi. Okay, low resistance means it's a zero value. High resistance means I'm saying ideally it is going to be infinite. Okay, so infinite value, but the current in a such a way that R such that the current flowing through the RL is 0. So current ikkada 0 అయిందంటే ఎంటైర్ కరెంట్ అనేది ఇలా వెళ్ళిపోతుంది. ఎంటైర్ కరెంట్ అనేది ఇక్కడ వెళ్ళిపోతుంది. సో ఇక్కడ 10 amperes కరెంట్ వచ్చింది అనుకోండి, ఆ 10 amperes current will flow through like this. What about the current here? 0 amperes. Okay, understand here, the current always prefer low resistance path. When you making this R value to 0 value short circuit, simply I can say short circuit here. when you're doing short circuit, the entire current will flow 10 amperes of current, for example, and the voltage here is going to be, the current here is going to be 0 amperes here. So that's it, friends. Please watch this video through online. If you like this video, please subscribe to my channel, and if you give your valuable suggestions, thank you. Have a nice day.